2.3 Solving Trig Equations, Part 2. So if you look at example 4, our first step is to try to factor. Well, I can't factor something that has a sine and a cosine. However, we do know that sine squared is equal to 1 minus cosine squared. So now it's about replacing us with trig identities that we know. So we can replace sine squared with 1 minus cosine squared, and we can simplify this equation into now I'm going to combine like terms, and then I'm also going to rewrite this so I don't have a negative out in front. And now I'm going to factor this. Now, because of this negative 1, I could divide that by 0 because I'm really solving. So I'm not factoring isn't my question. So I don't really have to have that negative 1. 0 divided by negative 1 is still going to give me 0. So I'm factoring this. My options for 2 cosine x is going to be 2 cosine x and 1 cosine x. Now the only option I have for a positive 1 is negative 1 and negative 1. So if we check this, this gives me a negative 2 cosine and negative 1 cosine, and that's where I get that negative 3. So now I can set both of these equal to 0. 2 cosine x minus 1 equals 0, and cosine x minus 1 equals 0. And I solve for both of those two equations. So it looks like I'm going to have 2 to 3 answers, and I know it's going to be 3 because of the fact that cosine's positive. So this is going to be in the first quadrant, which is all sad turtles cry, and also in the third quadrant right here. So cosine adjacent over my hypotenuse. That means this is square root 3 across. So for this problem right here, across from my square root 3 is going to give me my 60 degrees. So this would give me x is equal to, so in radians, 60 degrees is pi over 3. And again, you have to make sure to add on 2 pi each time because that's 1 period. And I also have this angle right here. This is also a reference angle of 60 degrees. So that would be 5 pi over 3 plus 2n pi. However, I have this third answer right here. So cosine x, remember cosine is going to be your x value. So here, this point right here is where x is equal to 1. So that point right there is at 0. So if I could write 0 plus 2n pi, or my final answer would just be the 2n pi. So again, if you wanted to write 0, because that point right there represents 0, these would be my 3 answers for this problem right here. Now for example 6, I'm not going to have an n with it. How do I know? Because I have this interval, it's telling us I want to solve it. So for this one too, we have 2 different trig functions. However, with these 2 trig functions, we don't have anything squared, so we can't just replace something. However, what we can do, whatever we do to one side, we can do the other. So I'm going to square both sides. One of the reasons I'm trying to square both sides is because we have that trig identity with cosine and sine when you have something squared. So remember, when you are squaring both sides, that means you're multiplying it by itself. So on the right-hand side, I'm going to have just the sine x. On the left-hand side, I have to do my foiling. If I did my first outside inside last, my 2 outside inside would combine with the 2 right here. So now, when I'm looking at this, now I can replace the sine squared, kind of like I replaced sine squared up there, to be cosine x plus 2 cosine x plus 1 is equal to my 1 minus cosine squared x, because that is equal to sine squared. So I'm going to move everything over to the left-hand side. Now I look to see what I can factor. So I can factor this by having a 2 cosine x on the outside, leaving me with a cosine x plus 1. So now I can set both of these equal to 0. Now here, that's an equal sign. That looks kind of like something else. Now here I have kind of a special circumstance. Again, I'm looking for 0 to 2 pi. So cosine is always going to be my x value. So if I'm looking at my x value, when is my x value 0? So that'd be here and here, because this would be 0, 1, and 0, negative 1. So I'm not going to have an n in this case because I'm looking for my interval. So this would be x is equal to, this would give me pi over 2. And this right here gives me 3 pi over 2. Now this also has a cosine -1. So again, that x value. So right here has that x value at -1, 0. So that x value is going to be, that angle is going to give me pi. So these would be my 3 answers for this problem. So now looking at example 7. So first thing that you notice, hopefully you notice, is that now there's a number right here. We haven't done anything when there's a number right here. So we want to first solve this like normal. Okay, so we have this -1, so it's add the 1 over, divide by 2. So we're going to get cosine of 3t is equal to 1/2. Okay, so right now, same thing. We're going to set up our quadrants. Cosine's positive in the first, all sad turtles cry, and fourth. So cosine is my adjacent and my hypotenuse. So this right here is going to give me my square root 3 over here. So my reference angle here is 60. My 6 degrees is my reference angle. So typically we would have that the t for this angle here, if this reference angle here is 60, that would be pi over 3 plus 2 pi n. That'd be equal to our answer. Then also right here, we would have 5 pi over 3 plus 2 pi n. That's if we just had the t. Now this is equal to 3t. So now to finish solving this, we have to get the t by itself. So I could divide by 3 here. Also remember, dividing by 3 is the same thing as multiplying by 1/3. So my answer here would be equal to, if I multiply each of these by 1/3, pi over 9 plus 2 pi n over 3. And then we also have here, again, if I divide by 3 or multiply by 1/3, 5 pi over 9 plus 2 pi n over 3. So if I look at problem 8, same type of thing. I need to get that tangent by itself first. So if I'm working my work backwards for tangent, we get this. Now this is again where you have to remember, tangent is periods from 0 to pi. So it's negative, all sad, so it's going to be negative in this quadrant right here. Tangent is my opposite, which is my 1/1. So this would give us our square root 2. So now I know that my reference angle here is 45 degrees. But typically 45 is pi over 4, 2 pi over 4, so this angle right here is 3 pi over 4. However, that's my x over 2 is going to be equal to my 3 pi over 4 plus pi n. Remember, tangent is period is pi. Now in this case, to get rid of this divide, we have to multiply all the things by 2. So my answer here is going to be 6 pi over 4, or 3 pi over 2, plus 2 pi over n. Again, this would be 6 pi over 4, which is also 3 pi over 2. So this right here is my final answer. Last but not least, okay, so we have a tangent, we have secant squared. We know that secant squared, because we're smart people, is 1 plus tangent squared. I also subtracted that 4 over. So now I'm going to combine like terms, which is this and this, and we factor. So this is like our x squared minus 2x minus 3. So what numbers multiply to get -3, add together to get -2. So we set both of these equal to 0. Now, when I set both these equal to 0, here I would add the 3. Here I would subtract the 1. Now, when I do this tangent of -1, I see that this is my x over my r. My y over my x. However, for this problem, there is no special right triangle ratio for 3. We don't have a 3 over 1. We have a square root 3 over 1, or 1 over square root 3. So for this problem, because of this right here, we have to use the arc tangent. Whatever you do to one side, you have to do the other. However you solve one equation, you have to solve the other. So what I have here is arc tan of 3. But again, because it doesn't have an interval notation, we know tangent is pi. So plus pi n, and then this would also give me an x is equal to arc tan of -1 of pi over n. However, this I can't simplify. This one I can. So this is where you have to remember arc tan is going to be my first and fourth. So since it's negative, I have this equation or this triangle right here, my opposite over my adjacent. So this equation or this angle right here is my negative pi over 4. So I can replace this, because this is in my domain, negative pi over 4 plus pi n. So these are my two answers for this last one. How do you know when to do this compared to actually write out the two separate triangles? Well, this occurs when one of them is not a special right triangle. So 3, ratio of 3 is not a special right triangle, so we can't find that using our radian measure. So those two are my final answers. And bing, bada, boom. That's it. That's all she wrote. Have a grand, and have a wonderful day.